Okay, so like we said, the solutions to the systems are going to be that overlapping area. And I know it's kind of hard to see on these graphs, but it's okay. We'll work it out because I'll explain everything to you. So we have in our first graph that you see, we have the area with the red dotted line, and everything is greater than that. You should see the red shaded area that's above that. And I'm going to circle, or not circle, but I'll point to, we've got this whole area here has the red shaded area. We also have our blue shaded area, so that is less than this line. So our goal is to identify which part of this is overlapping. So if we look, we've got that red area, that blue area, and I'm going to use purple to show you where they overlap because red and blue makes purple. So this area in here, you can see you have both red and blue in there. So that purple area denotes where the solutions are. So if we look, we have that red dot right at 6, 2, and that red dot falls within the purple area. So that means that this red dot, that is a solution that can be included in part of the solutions to this system. So if we look at the second graph that we have, we've got that red area. I'll circle it for you. So the red goes all along here, and then our blue goes around here. So what we have overlapping is a really narrow area. Right in between here. We'll try and make it a little more obvious because it's getting a little messy. Okay, so that's where it's overlapping in that purple area. So if we look at the point that we have at 4, 0, we look and that does not fall within the purple area. So that means that can't be a solution. It's not in the area that's overlapping, so it's not a solution. So just as a little bit of a summary, if you have a point that falls within that purple area, at least on here it's purple, that overlapping area, that can be a solution. There are multiple solutions, but that is one of them. And if it does not fall in that shaded area that's overlapping, then it's not a solution. We're going to use that when we're solving these next. So when we solve systems of linear inequalities on our next example that I show you, in the end, we're going to need to be able to give 2 examples of solutions and 2 examples that are not solutions. So if we're given a system that we need to solve, our example is going to be 8x plus 4y is less than or equal to 12. And then y is greater than 1/2 x minus 2. We're going to solve this by graphing it, and that's really the best way to do it. That way you can see where all the overlapping areas are. If we look though, if we're graphing, we need everything to be in slope-intercept form. And hopefully you've noticed that first one is not in slope-intercept form, so we're going to need to move some things around. So we need to rewrite it. And then our goal is to get y by itself. So in order to do so, we need to subtract 8x from both sides. So it cancels out on the one side. We're left with 4y less than or equal to 12 minus 8x. And then we need to divide by 4. And remember, when we divide by 4, we need to do both the 12 and the 4, and then negative 8x and divided by 4. So we've got y left over, and 12 divided by 4 equals 3, and negative 8 divided by 4 equals negative 2. And we're going to go ahead and switch those two around just so that we know we've got the slope and the intercept. So now we have both of those put into slope-intercept form, so we need to go ahead and graph those. If we use this first inequality that we have, we need to first identify the intercept, so hopefully everyone can see that the intercept is that plus 3 on the end. So we need to go ahead and plot that. So we put the point at 0, 3, and then the next thing is to decide whether or not we need a dotted or dashed line or a solid line. So we look at that inequality symbol, it's less than or equal to, so we need a solid line. And our solid line has a slope of negative 2, so we're going down 2 and then to the right 1. Okay, so down to right 1, so we've got a point right at 1, 1. Then you can keep going. And then we can do the same if we go up 2 and to the left 1. And then we need to go ahead and put in that solid line. We have that one line graph now, so now we can look at the y greater than 1/2 x minus 2. So we have an intercept of negative 2, so go ahead and plot that on your graph. So down on the y-axis, negative 2. And we need to decide if it's a dotted or dashed line or a solid line. And since we have just the greater than symbol, we should know we have the dashed line. So make sure you keep that in mind as you're graphing it. Go ahead and do your slope. It's 1/2. So we have the rise is 1 and run is 2. So up 1 to the right 2. Go ahead and start marking off those points. So up 1 over 2, 1 over 2. You can also go down 1 to the left 2. And then we need to put in our line. Once you've done your dashed line, that's when we need to start doing all the shading. And so hopefully you can see everything pretty nicely on here, even though it's a little bit difficult when we highlight. So let's look at that first one again that's in red. Y less than or equal to negative 2x plus 3. Now that means it's less than that line. So a good way to remember where you should be shading is to look at that intercept. So we're looking at that intercept 3, and y has to be less than that, so that means we're going to be shading the areas that are 2, 1, and then down into the negatives. Okay, so that's everything in this area, and you should start to see where maybe it will overlap with the blue. And what's in blue? The y greater than 1/2 x minus 2. So we can look at that intercept at negative 2, and y has to be greater than it, so the numbers that are greater than it are negative 1, positive 1, and so on. So we need to go ahead and shade those areas in. So our overlapping area, we'll put it in purple. You don't have to circle this because it's hopefully more obvious on your graphs that you have in your notes, but I'll go ahead and make sure we know where that overlapping area is. It's right in here. So now, the very last step, we're almost finished. We need 2 points that are in the solution and 2 that are not. So let's start with the 2 that are in the solution. Let me get rid of some of this work over here so that we have space. Okay, so the 2 that are in the solution, we can just look at the graph. We can pick a random point. Let's say that I want to do, it could be anything. So we could do -4, 3. That one's in the solution. And then also we can do -6, -1. So as long as those fall within the purple area, they can be solutions. So I'm going to put them in green because green means go. And that's always a good thing. So -4, 3 was one of them. And then the second one is -6, -1. So then we just need to look at the ones that aren't solutions. I'm going to put those in red. So you can just pick anything that doesn't fall in that purple area. So 2, -4. And we can do 3, 2. Neither of those work. Alright. That's it for this one.